Okay, data-informed decision-making framework. There are 7 steps, as you can see here. And before you ask, there are several frameworks out there for data-informed decision-making, and some have 6 steps or even less. Others have 8 steps or more. They're not wrong, but for the project management practice and space, I believe that the 7 steps are the most appropriate ones that need to be considered here. And you see this especially in the problem definition part. So these are the first 2 steps. So you see that, and that's different from others where I've basically taken this apart. So I have identification of a problem and a framing of a problem. And we will look at this based on one example, what that actually means, what's the difference here, right? But effectively, you clarify the problem, you define it properly, that is really clear. That's identification. At the same time, you need to frame the problem, meaning, are we really looking at the right thing? Or are we just looking at some symptom of something bigger, some other root cause? So this is basically the difference. And as I said, we will look at an example in a minute. And to make that a little bit more tangible from a concept point of view, what data-informed decision-making really means, I came up with this example here in terms of the navigation system in the car that we're all familiar with, right? So what happens? I think we're all familiar with this, how that actually works. But it's not working just by pushing a button and it spits out, whichever way we need to go, right? It needs first input, right? We need to tell the system what we want. And we need to elaborate the problem. We need to define the problem and be as precise as possible. So, for example, I'm in Switzerland, and let's take another example. If I want to go to, I'm saying I want to go to New York, right? So I put it in there, New York, give me New York. So is that precise? Not really, because what street number, what street address and number and so forth, right? Because New York is a big city, right? So if I don't provide that, that system will just go by an assumption. It will assume that I will want to go to the city center of New York, and accordingly it provides recommendation, but it may not be helpful for me because I don't want to go to the city center. I want to go to a particular street. So the point is, precision is really key here to make it as useful and insightful as possible. And I want to walk this through just briefly before we actually go to a more practical project management example. Let's take that example a bit further and drive that through the process in terms of problem definition. So, and you see here, this is applying the SMART method. I'm sure you are familiar with, right? When we define goals, we want to be specific. It should be measurable, time-bound, actionable, relevant. So these kind of aspects also very handy here when it comes to problem definition in this decision-making process. So we clarify the goal by stating first what the problem is, and then go through the different steps to make it more specific. So let's say as an example, we need to get to a work meeting, at the office, for example, right? So that's our problem statement, and we need to take a decision how to get there, right? Is that specific? No, it's not. We don't even know where is the work meeting, right? And what is this all about, right? And what are the different parameters to get there? So that's where we get more specific. So where is the meeting, right? So it is in the office, and the office is in Main Street 5 in Zurich, Switzerland. That's already helpful input, which obviously a navigation system would need, right? So I need to travel from my current location to Main Street 5. All right, good, we have that. then we need to make it more measurable by understanding how does success look like, right? So we want to get there, but what are the constraints, right? So we need to arrive at 2 p.m. at the target location, at the office. Okay, that gives us some more information to define actually how much time we have, how much time we have available to reach that target location. So we're saying we want to get there as fast as possible, but the journey cannot take longer than 20 minutes because right now it's 20 to 2, let's say, right? So we have only 20 minutes, right, to reach that location, right? That's all what we have, right? So that's the constraint, but ideally as fast as possible. So, and make it actionable, meaning also, I mean, what needs to get done, but also is it realistic even, right? So if I'm saying, I'm based in Switzerland here, if I'm saying I want to go to New York in 20 minutes, I want to be there, I reckon that's not achievable and not realistic really, right? So this is one question to ask, right? But the other thing is, what do we really need to do right now? That we have some actions that we can work with. So in this particular case, we want to find out which route is the fastest to arrive at 2 p.m. at the target location. And maybe we actually have different means of transportation that we should consider, because public transport may be even faster than going by car, right? For example. And last but not least, make it relevant, meaning what is actually the problem, right? We know we need to get to a work meeting, but give me more, right? Give me more around this. So we find then out we need actually to do a presentation at this particular meeting. That's why we have to be there, right? So it's relevant. It's more about why. So why do we have to get to that work meeting in the end? We have to do a presentation. And that is helpful information, which also goes then into problem framing, because maybe this particular problem I need to get to a work meeting is not really the real problem. Maybe the real problem is that we need to solve is to actually ensure that we can do a presentation at that meeting. And that doesn't imply that we actually have to drive there. Now, we can actually do, for example, some virtual meeting, some online meeting. That could be a solution, right? So by asking those questions and going to narrow that down further, we actually frame the problem even to understand what are we really looking at? What do we want to resolve, right? So this is really important to define the problem and identify the real root cause and something that we want to look at. So this is about this navigation system problem, but let's look at one example in the project management space. So let's take that same approach here, right? Let's specify the problem. So let's say, and I have a background in software development projects, so I'm familiar with this, of course, but here we're saying, lately we have seen frequent quality issues with software project deliverables. Okay. Is that precise? No, not at all. Lately, what does that mean? Frequent, what does that mean, right? Quality issues, what is quality? Well, how do you define quality, right? And we don't even know, okay, software projects, okay, fine, but are we looking at all software projects in all different areas in an organization, or just a particular domain? We don't know. We are missing certain information, right? So let's go through this whole process again, right? So we have being more specific, right? So we are questioning what means actually quality issues. How do you come to this even, right? That there's a quality issue, right? Yeah, because new introduced features in those releases, software releases, they were broken and they needed to be reworked. Okay. We understand right now new introduced features, right? So we come closer to the actual problem here. Measurable. So it was talking about frequent quality issues lately, so we didn't really know what that means. So to make it more measurable, we understand right now that the number of defects increased of those introduced features. It's not like all the introduced features were broken, but there obviously were defects, but they increased by approximately 30%. And it should be a maximum of 5% defect rate. Here we have a missing information increased by approximately 30%. So you compare that, I mean, what has been compared, right? So there's a time factor in there. So we're looking at quarter Q3 results, right? And we compared it to Q3 results from the previous year. That's where the 30% are coming from. So that's where we see a difference, right? That makes it already much more meaningful in terms of the problem statement. And actionable, that all this information gives us already some more input here, but what we ultimately have to find out is really what has changed, right? From quarter Q3 previous year and then this current year in terms of these particular projects, right? And processes, people, project metrics, a lot of things could have happened, right? But something must have changed. And that's what we want to find out. But in this context, we also need to understand more background, or in terms of relevancy, right? What are we actually looking at, right? Give us a little bit more, right? So we understand then, by asking those questions, yeah, we have a risk of not meeting regulatory mandates because that particular software or these types of software are actually regulatory compliance tools. I mean, they're in compliance, right? Oh, okay, we're looking at the compliance domain. So we have narrowed that down, right? So we need to find out what changed for the software projects in the compliance domain between these two quarters. And problem framing is really like to understand, are we solving the right problem? So I've summarized this, what we just had on the previous slide, in terms of the problem summarizes as software project deliverables with high number of defects. Obviously, we have all these different details that we elaborated already, but let's put this way right now: the software project deliverables with higher number of defects. That's our problem to solve. So if you just look at this, especially if you're familiar with software project management and this whole process behind those, right? Then one solution that could come to mind, especially because we're talking about defects, we're talking about quality before, right? Could say, yeah, then we have to look at the software development process, right? Maybe something is wrong. Maybe we have to scale up people, or maybe they're not really that diligent in terms of validating their code and this kind of things, right? So maybe we should introduce pair programming as a measure to improve the quality, right? That could be one solution. But is that the right one? Is that actually is that even the problem that we want to solve or need to solve? So that's where the problem framing concept comes in. And we need, as part of this, we need to ask a few questions, right? And they're sometimes obvious, sometimes not so obvious. So it's all to be questioned from different angles, right? So for example, in this case here, what triggered the quality problem in the first place, right? Why do we have this problem only in the compliance domain, right? In other areas, maybe that's not the case. The same with the processes that we're using. This is actually different than in other areas. Maybe that's the problem. Or are we even already implying the solution by stating the problem, right? Which could be misleading. Or, there's something obviously happened between Q3 and previous year and the year in question. Something changed because we're saying, the failure rate or the defect rate increased, but before it was obviously acceptable. So something must have changed, right? So what is it, right? It's not necessarily the software development process or the skills, maybe something else, right? We have to look at from different perspectives. There are different viewpoints, but we have to shed a light on all these different viewpoints and perspectives. And that's where the problem framing is very, very useful. And there's the metrics. That's one method. There are different ones actually when it comes to problem framing. That's called the reframing metrics. There are different techniques, but this is one and it has these 4 quadrants, which each of these quadrants represents a perspective on the problem, and each can have different labels depending on the nature of what we're looking at, right? So in this particular case, it's product planning system people. So the product, in this case, it's a software that gets produced and the requirements behind this, right, that makes up that product. Is there anything wrong there in terms of, have we overlooked something in terms of requirements? Is it all clear what actually the user want, and this kind of things, right? Then we have the planning approach, right, where the project's actually planned the right way, or is there any issue in how we plan this and schedule the projects, right? Does it all make sense? Does it all add up, right? And people is about the people that actually working in the project or are affected by that project, right? There could be stakeholders, right? Change management teams. It could be the development team that we mentioned, right? Is everybody collaborating? Are we having some cultural issues maybe, or communication issues, anything of that sort? And system is all about everything that's surrounding, but where are some dependencies like infrastructure and this kind of things, right? And process in general. So all these elements are perspectives. So if we look at the product and requirements, we actually, let's say we investigate this, we do a deep dive, and then we realize actually the requirements are clear, stable, looking all good. So nothing really changed. So can't really say that here's a particular problem. Okay, but it's good information. We have that. In terms of the planning part, so here, as an example, we find out that those projects that we are looking at, they are frequently running at risk of overrunning the schedule targets. They may get delivered on schedule, but it's often really like a stretch. They're actually missing some intermediate milestones, and then everything comes in last minute. Everything is becoming kind of a stretch, which indicates some sort of a planning issue, which needs to be looked at further. In terms of people, we realize, again as an example, that over the last year or last 12 months, several new project managers were hired. They're all brand new to the organization. They're maybe not even fully familiar yet with the different details of the organizational processes, and that could have some impact, right? And we also see that the people in the project, they often have to work long hours. It's all a stretch. Sometimes weekend work, and people get exhausted and tired, etc. Right? So this could have some impact as well on the quality. And system, we even discover that we're actually in the middle of a change from traditional to an agile methodology in these projects in question, in these compliance projects. So there's a transition going on. So new process. So that definitely also could have some impact on the outcome from this project and the performance and the quality in the end. So considering all this, and if we do a real deep dive and uncover all these elements, right? Looking back at the original problem, software project deliverables with high number of defects, is that the problem, or is it just a symptom? We could realize based on our deep dive that the real problem is actually that we have an issue with project planning. It's rather inaccurate because of the new project managers who are not really fully familiar with certain processes. We realize that we're missing often the intermediate milestones, which certainly must be an issue with project planning then. And as a result, people often have to work long hours, right? And on top of it, there's a change from traditional to agile approach, which probably just adds to the turbulence in these projects. So the problem that we ultimately, through this whole reframing, identified is something else than what we originally perceived as one. So the quality issue is rather a symptom, and that is the problem that we need to look at. And here we take that further and get some more context, right? To also have some more defined actions and ultimately also know what kind of data we should look at to analyze that further and come up with a solution and a decision in the end. So in terms of the context, we heard already before that there's a regulatory risk which is increasing, and that is due to this delays on regulatory commitments because we have to rework the software. We always running a little bit behind. So that ultimately means also that we have some high urgency to get it resolved. And who is actually asking? Head of compliance, compliance people, external regulators. That's all valuable to know because we have to align with them in terms of the next actions. And what are we seeing as the next action in this particular example? We say, that transition to Agile, just park it for a moment, just apply the traditional approach in the interim, and do some more training on the side in Agile so that we actually don't interfere here, right, with our goal to resolve this particular problem. And we have to review the planning approach and ensure that they have at least that accuracy and planning safety as in Q3 and previous year, because there it was acceptable, while right now it actually decreased in terms of the accuracy. And ultimately what that means is, in terms of information, we should look at project schedules because the time factor is obviously critical here and triggers then these quality issues, these constraints. So we have to look at the project schedules from how it was done at the moment in Q3 and then also in the previous year to make the comparison, right? And then also look up some schedule risks, potentially some other data, right? But just to simplify that here, we look at schedule data that we want to collect. So in terms of collecting data, we can then ask several questions, right? So how many days software products in the compliance domain were overrunning, their schedule targets. So we compare that ultimately then also to the previous year, how the overrun looked like back then, and what were the common risks, right? But the first action really is to make that comparison and to understand where the gap is. And if we see, like in this case, that the projects were actually not properly planned, the schedule is really too tight, and we need to either increase the workforce, the people that are actually working on the project, or we just need to stretch the schedule. That's obviously some insight that we get out of this, and that can be taken to the decision maker.